Hello, sir. This is Purnima.
And this is Divyansh.
Today, we are present here for a video presentation of subject operating system and cloud computing. Getting straight to the point, let's begin. You might know the 17 UN Sustainable Goals. The Sustainable Development Goals or Global Goals are a collection of 17 interlinked global goals designed to be a blueprint to achieve a better and more sustainable future for all. It is believed that people who work on sustainable development will have a long-term life of their project. Keeping this in mind, we had tried to highlight the third sustainable goal, that is, good health and well-being. Good health is the only resource that allows people to live a long, productive, and fruitful life. Taking care of your body is a must as it is the only place to live in. But is our current generation taking care of themselves? Unfortunately, no. In today's world, the important thing that matters is health. People have become more health conscious and are careful about their diet. Due to the fast-moving world, obesity and other related issues become a major health problem among human beings. Obesity is a complex disease involving an excessive amount of body fat. Obesity isn't just a cosmetic concern, it's a medical problem that increases the risk of other diseases and health problems such as heart disease, diabetes, high blood pressure, and certain cancers. A million people die yearly due to obesity. The cause of obesity is stated by World Health Organization as an energy imbalance between calories consumed and calories expended. Nowadays, it is very difficult for a person to track the calories consumed by them. The intake of calories play an vital role in one's healthy lifestyle. Earlier, the users used to track their calorie intake with the help of charts. These methods are very hectic to follow and lead to an unquantified meal diet. Having a meal which is quantified helps you reduce the extra fat. We came up with an idea to help the people track the number of calories, hence introducing Calorista. Many people have the difficulty choosing food items that have good nutrients and low calorific values. Our proposed system not only detects variety of fruits and vegetables but also provides calories in vegetable and fruits detected in a single image. How wonderful it will be if a system can help the people and give them suggestions about the food and its calorific values. We can find a solution for this obesity problem. Now, Divyansh will further explain about Calorista, the web app.
Okay, so let's see how the web application works. Okay, so first we will look at the tools and libraries that we use to develop the web application. Keras, we used for deep learning tasks like creating the model and predicting the objects, etc. Pillows and NumPy. Pillow we used for pre-processing the image of our dataset and NumPy for image matrix handling. Streamlit. We used it for backend and frontend of our web application. Beautiful soap and requests. We used it for scraping the calories from the web for predicted object. Okay, so it is a bit confusing. We have used Streamlit library, that is a Python framework. We used it to build front-end and back-end of our web application. And there is a Streamlit Cloud, that is a workspace for developers and their team to easily deploy, manage, and collaborate on the Streamlit apps. It is popular for machine learning application and it is not very complicated to deploy a machine learning app on Streamlit. So we used it to deploy our web application Calorist. Before looking at the workflow, let us have a small insight on the dataset we used for the model. So, we used fruits and vegetable dataset which we found on Kaggle. The dataset has 36 classes and almost 100 images for each class. So we have around 3600 plus training images. For testing and validation, we have 10 images for each category. So, this is the workflow of our web application. We have divided our modules to make the task easy. The front end and back end is handled by Streamlit. As a normal user, the user will visit our application by URL. First, the user will upload the image which will be stored in the system. Using Pillow, the image will be resized according to our model shape. Then it will be converted into a vector using NumPy. Now, the vector will be passed to our model and our model will classify the class of the category. We will get the ID of the category. So we need to map the labels according to the ID. Now, our system will display whether the image uploaded contains fruit or vegetable and then the name of the fruit or vegetable. A button will appear asking to find calories. If we click the button, our system will web scrape the calories present in 100 grams of the predicted object and will display these results. Now, as we have seen the workflow of web application, it is time to see the application. So, we have actually linked the link of the application in the presentation itself. So, if we click it, it will open. Okay, so directly moving to the Calorista. So, this is the user interface. Here we need to upload the image. So, for image, for testing images, we took two images. First one is grapes, that is a fruit, and the second one is carrot, that is a vegetable. So let us see how our model will predict the objects. So we'll have to browse. We'll select the first image. As explained in the workflow, the image is displayed. The category is displayed that it is whether a fruit or a vegetable. So it is a fruit, and the name of the fruit, that is grapes. So here the button has appeared to find calories. If we click, our system will web scrape the calories present in 100 gram of grapes and then display it. Image. Yeah. So it displays that grapes has 62 calories present in 100 grams. Now let's look how many calories are present in carrot. So carrot is there. The category is vegetable. Carrot is a vegetable, and name of course is carrot. Now again, if we find calories, it will present. I click the home by mistake. Yeah. So if we find calories, yeah. So it says 25 calories per 100 gram. So there's two less calories. So why not eat carrots instead of grapes? So now moving to the presentation now. So everything has limitations and scope to improve. Let's discuss what we can do better. Currently, our application can only classify when there is a single type of fruit or vegetable present. We need to make it versatile so that it can work well if there are more than one type of fruits or vegetable in the image. Right now, it calculates the calories present in 100 gram of the predicted object and not the actual calories. For this, we can calculate the volume of the fruit and then calculate the actual calories. Since the user need to upload the image, it is not that user friendly. To improve this, we can integrate our application with mobile cameras or a mobile application, which can be a better interface for our model. So that this is all about our project for operating system and cloud computing. We not only learned how to make and deploy apps using cloud services, but also learned that we can integrate ML models with web applications so that real world users can interact with the app. We hope now whenever your body fat peaks out, make sure to use Calorista. Thank you, sir, for this great opportunity.
Signing off.